Okay, we are starting chapter 11, which is all about unsaturated hydrocarbons. In the previous chapter, we talked about alkanes. In chapter 10, we talked about alkanes, which are all single bonds. However, this time we're talking about alkenes and alkynes, which are ones with multiple bonds in them. So we're talking about the difference between saturated and unsaturated hydrocarbons. In saturated hydrocarbons, the maximum number of hydrogen atoms are attached to it. What that's really meaning is when you're looking at this, they will all be single bonds. So if you see a double or triple bond there, that means you have an unsaturated hydrocarbon. But if you see all of them being 100% single bonds, these are saturated. All of the carbon bonds are used up. Unsaturated, however, have double and triple bonds associated with them. So if you see a double or triple bond in the molecule, you automatically have an unsaturated hydrocarbon. Double bonds are called alkenes, and hydrocarbons with triple bonds are called alkynes. Notice the ending of the word. That becomes important in both scenarios. Before, we were dealing with alkanes, as I said earlier. All the words ended in A and E. For instance, this one, because there's two carbons, would be ethane if that was a single bond. Notice, however, it's ended in E and E because of the double bond. Well, double bonds are alkenes. That ending of the word is the same. And down here is a triple bond. While triple bonds are called alkynes, this is ethyne. Notice the difference between ethane, which is a single bond between the two, ethene with a double bond, and ethyne with a triple bond. That's the naming differences for the ending, for the suffix of the words. So when we're looking at the bond angles of alkenes and alkynes, when we were looking at alkanes in the last chapter, there were 4 things coming off of each carbon. That gave the bonding of 109.5. Notice it's higher than 90 degrees because it's in 3 dimensions. It's not flat, so it's think of a bubble or a balloon that's trying to fill up all the space it can. Whereas with the double bond, this actually becomes a flat molecule, whereas this one isn't, whereas the alkanes are not. So that makes this bond equal 120. And then if you look at the alkyne with a triple bond, this gets stretched out to 180 degrees. So it goes from 109 to 120 to 180. The bonds get further and further apart. The electrons are repelling from each other as much as possible. Remember, Vesper just simply is talking about the shape of the molecule. So just as a little bit of background, ethene is a simple alkene. It's the simplest one, just 2 carbons with a double bond. It's actually used for ripening of fruits, so they'll spray it on there. And here's some more alkenes that you might be a little bit familiar with the aromas of them. For instance, this would be the aromas for roses. Notice the double bonds here and here. Now you may remember from chapter 10 that the OH group is an alcohol. And we have bay leaves, more double bonds here, and lemongrass. This you might remember, see double bonded OH, that's an aldehyde. That once again was from chapter 10. And then we have lemons, double bond here and here. Acetylene, or ethine, is the most simple of all the triple bonds, and it's used to help with the welding. Now, naming alkenes and alkynes are very similar to naming alkanes. You're still going to try to find the longest chain. But this time, you're going to want to find the longest chain that contains the double bond. For instance, we have 4 carbons here. So 4 is short for bute. 4 carbons. E and E is because there's a double bond. And then this 1 here means that the double bond is on the first carbon. When you number the carbons, you're going to want to begin with the side that's closest to the double bond. So if we look at the second one, 1, 2, 3, 4 carbons, we still have the bute there. E and E because there's a double bond here. And when we're looking to count, 1, 2 is on the second carbon. If we counted from the right hand side, it still would have been the second carbon. So, on our last example, there are 5 carbons. This is actually a typo. That should say E and E, not Y and E, because it's a double bond. If it was a Y and E, this would have to be a triple bond here, not a double bond. So, if we count it from the left, like we did before, that would put the double bond on the third carbon. If we count it from the right, however, 1, 2, it's on the second carbon. So we want to get the smallest number possible. So that means these are not good. We're going to count from the right hand side. So let's practice some naming. First thing you want to do is find the longest chain. So here's the double bond. We want to make sure our double bond is in the chain. So we're going to start here. And there's our double bond, or there's our chain. 1, 2, 3, 4. There are 4 carbons in our longest chain, which means it's going to be bute, because there's 4 carbons, ending in E and E because we have the double bond. Circle and label the substituents. Well, here's the only substituent, all the rest are hydrogens. This is methyl. Count carbons starting with the side closest to the double or triple bond. Well, that would make it on the left. So 1, 2, 3. So that means on the third carbon there's a methyl group. So name the substituents with appropriate carbon number and chain. And that comes out to be 3-methyl. We have to state which carbon the double bond is. So 1 bute, because there's 4 carbons total, and that's where the double bond is. There's a double bond, it's on the first one. Try it again. Find the longest chain. Well, here's our longest chain. 1, 2, 3, 4 carbons again. So we're sticking with bute. It's going to end in E and E because of the double bond. Circle and label the substituents. Well, there are none here, so we don't have to worry about that. Count the carbons starting with the side closest to the double or triple bond. 1, 2 from the left, from the right it's 1, 2. So either way, it's going to be the second carbon. So name it. There's no substituents, so it's going to be 2-butene. Right. Find the longest chain. Here's the double bond. Here's my longest chain. Once again, we're sticking with 4-butene. Circle and label the substituents. 1, 2, 3. We have 3 substituents here, and they're all methyl. So that means combined is trimethyl. Count the carbons starting closest to the double bond. 1, 2, 3, 4. So when we're naming it, we have 2 and 3 and another 3 because there's three methyl groups. So 2, 3, 3 trimethyl. 2, 3, and 3. And then 1, because that's where the double bond is, butene. Alright, let's try one with the triple bond. Here's our longest chain again. 1, 2, 3, 4, 5, 6. So there's 6 carbons this time. That's hex. But there's a triple bond rather than a double, so that becomes YNE rather than ENE. Circle and label the substituents. Well, there's our only substituent, and that's methyl. Count the carbons. 1, 2, so on the second carbon is the triple bond, 3, 4, and then on the 5th carbon is the methyl group. So 5 methyl, 2 hexyne. On the 5th carbon there's a methyl group, 6 carbon chain. On the second carbon there's a triple bond. Alright, so let's do some more practices. This time you don't have the cribs. Don't have the steps. You have to figure it out on your own. I'll give you a minute to think about it. Alright, let's get started. You have 4 carbons there, so that's bute. You have a double bond, so that's ENE. And on the first carbon is where the double bond is located. There are no substituents here. Part B, once again you have 4 carbons, so that gives us bute. There's a double bond, so that ends in ENE. There are no substituents, so 1, 2 on the second carbon is your double bond. C, 4 carbons is bute. You have a double bond, so that gives you ENE. You have a substituent, and that's methyl. So we start counting from the side that's closest. Well, we can do 1, 2, or 1, 2. But I'm going to go from the right because not only is the double bond on the 2, but if we go with the methyl, it would also be on the 2. Whereas it would have been on the 3 if I would have counted from the left-hand side. So on the second carbon of the 4-carbon chain, there's a double bond. And then also on the second carbon, there's a methyl group. And then finally, we have a triple bond here. So it's still 4, so it's bute. But this time it's YNE. There's no substituents. So on the second carbon, there's a triple bond on the 4-carbon chain. Okay, a few more. I'll give you a minute to think about these. Alright, 1, 2, 3, 4, 5, 6. That means hex. It's a triple bond, so it's going to end in YNE. There are no substituents here, so I can move on to counting. So on the second carbon of the 6-carbon chain, there's a triple bond. The next one, here's our chain. 2, 3, 4, 5. It's pent. Double bond, so ENE. There is a substituent on this one, and that's the methyl group. If we count from the left, double bond is on 2. If we count on the right, it's on 3. So we're going to count from the right hand side. So that's 2 pentene. That makes a methyl group on the 3rd carbon. And there you go. And that is all of naming alkenes.